Hi everyone, my name is Lenae and this is going to be my Barbie screencast for my group. First I'm going to start talking about the diagram. So in this first part is how many actually centimeters that was converted into meters, how long the Barbie had to go down, and the conversion is right over here. And down here is when she was fully stretched and the height that she went when she was fully stretched. And the last part is when she was just hanging there after she had finished jumping. So we had to use 20 rubber bands for our Barbie project. So now I'm going to show you our Excel spreadsheet. Up here is our data for our choosing of rubber bands. It just goes through 2 through 7 rubber bands and what was measured in centimeters when we dropped the Barbie. And then down here is a graph with all of our numbers, and we're looking for 289 centimeters because that's how long the Barbie has to fall. So we're looking down here, 289, and then we want to scroll down once it gets to the point, and we want to scroll down, and we get to 20, and that's how we found out 20 rubber bands. So now let's go back here. And as I explained, these are our conversions that we use to solve our energy calculations down here. And our first energy calculation was the gravitational potential energy before the Barbie had fell down, and it was 2.49. We figured this out with the mass, the gravity, and the height. And we use the same equation over here, but we had to change the height because when she was fully stretched, the height is different from when she was not moving. The next one is the KE, or the kinetic potential energy. And in the kinetic potential energy, you need to find out it was the person moving or was the object moving. And in this case, the object was not moving before. She was just standing up there waiting for her turn. And the kinetic potential energy fully stretched, and when she was fully stretched, it was also 0 too. She was just, well, yeah, it was also 0 too. And the elastic potential energy before, there was no elastic potential energy before because she was not, nothing was pushing or pulling against her, so there was no need for elastic energy. And this was when it was fully stretched, and in the end we got 2.43 for the elastic potential energy at the bottom. And then we used that number to find our spring constant, and our spring constant was 21.09 newtons over meters. And that was our spring constant. And I saved the best for last. We had, in this last conversion, we had to figure out how long was it going to take before the Barbie was going to hit her head on the floor. And it was 7 centimeters, and when you convert it, it was 0.07 meters. So now here's our slow-mo video, and then I'm going to show you how we figured out how many centimeters left she had to go. So first we're going to watch it, because this is exactly what we did. We are going to watch it first. And now we're going to stop it on the line when she's fully stretched. So, well, she was more stretched than that. Let me try this again. That's about it. It was kind of in the middle, so it's kind of hard for us to see what exactly she stopped at. So we rounded it to 7 centimeters, and then we eventually converted it into meters. And this is our Barbie whiteboard, and for our Barbie project. Thanks for watching.